Hi guys, welcome back. Today we are going to start looking at proofs with angles, and just like we did with the proofs with segments, we're going to look at some properties and definitions and things like that that you will be using with angles. So let's go ahead and get started. What property of angles could I use if I'm given that diagram? Well, I have a diagram, and in there I have one large angle and I have a ray coming out of the vertex. I don't know where that ray is coming out of. I don't know if it's in the middle, if it's breaking it in half, if it's anywhere in there. All I really know is I have one big angle and there's two parts that make it up together. So if I'm thinking here's part of the angle and here is part of the angle, all that I really can say about that is, oh, I have a whole angle, so I know my whole angle is CAD. So let's go ahead, and one of the things before we start labeling things here is to go into our diagram, and I'm going to erase where I put the word part. And to make our lives a whole lot simpler, so I don't have to call my angles angle CAB and BAD and ACD and things like that, I like to label them with numbers. So what I'm going to do is I'm going to call this angle here, this top angle, I'm going to call that angle 1. And then I'm going to call this bottom angle here angle 2. That just makes it easier when we start writing things out to describe them. The more letters you have in there when you're describing or naming your angles, it gets a little bit more confusing. So all I can really say is I have, again, this whole angle, and it has two angles that make it up. So I can say that angle CAD, which is my whole angle, equals the sum of its parts. So CAD is going to equal angle 1 plus angle 2. So we could put that in a proof if I'm just given a diagram. Again, I could just put this same thing in here. I can say angle CAD equals the sum of its parts, which is angle 1 plus angle 2. Well, when we did this with segments, we called it segment addition. Well, when we do it with angles, we call it angle addition. So anytime we take two angles and add them together, it's called angle addition, which is fairly logical, right? Okay, so let's look at some more. All right, this one, okay. Couple things I notice here is there's a little right angle right here. If you either see that it is marked with a right angle or you see the word complementary, complementary again is a vocabulary word, okay? So if they tell us this given information, they say ABC and CBD are complementary, that's given, then we think, okay, if they are complementary, I should have a little bell in my head saying, I hear the vocabulary word complementary. What is the definition of complementary angles? Well, that means that the two angles add together to equal 90 degrees, okay? So what I can say is I can say, and again, I'm going to come over here just to make our life a little bit easier, and I'm going to label angle ABC angle 1, and I'm going to label angle CBD angle 2. That just makes it a little bit easier when we go to write our proofs, less letters in there. Okay, so I know that they're complementary. The definition of complementary tells me if I add them together, they equal 90 degrees. So I can say that angle 1 plus angle 2 equals 90 degrees. And my reason, again, I have a vocabulary word in my given information. My vocabulary word tells me I can use that definition. So the definition of it is that they add together to be 90. So I can say the reason I can say that is the definition of complementary angles. Okay, same thing if you see the vocabulary word linear pair or supplementary. We're going to probably start using those fairly interchangeably now because linear pairs add up to 180, supplementary add up to 180. The only difference is that linear pairs are adjacent and supplementary angles don't have to be, but their definitions are very, very similar. So if I am given angle 1 and angle 2 are a linear pair or supplementary, again, I should have a little bell in my head that's saying there's a vocabulary word. What's the definition of supplementary? Well, it means the two add together to equal 180. So I can say that angle 1 plus angle 2 equals 180. And the reason I can say that, oh, it's a vocabulary word. That's the definition of the vocabulary word. So that is the definition of supplementary. Okay, so let's actually use some of those properties that we were just talking about to write a proof. So we look at our information here, and it says that angle 1 and angle 2 are a linear pair. Okay, so in my mind right now, I should have a little bell going off that says I see a vocabulary word. I can use a definition there as one of my next statements that I'm going to make. And I also have another given information. I have that the measure of angle 1 equals 135. That little m out in front says measure. Okay, so that's what we're talking about when we have that little m. So let's go ahead, first things first, look at our diagram and let's label some stuff. So we just have things that are making sense to us. They're a linear pair. You can see that in the diagram. We also know that angle 1 is 135 degrees. Okay, and some of you might be saying, well, I can see that. I can see that it makes a straight line, so I know that angle 2 has to be 45, but we have to show reasoning to get there. So let's go ahead and write down our given information, and we can say that angle 1 and angle 2 are a linear pair. And that is given. Okay, the given information doesn't say anything. It doesn't, you can't just write down 180 degrees. That's another step we have to actually put in there. And then at this point, some people like to write down all of the given information at once. Some people like to put it in at different times. I'm going to go ahead and write all of our given information down at once. So the measure of angle 1 equals 135. That's also given. Okay. So, like I said, your little brain should have had a bell going off that says linear pair. That's a definition. Okay, that's a vocabulary word I can write a definition for. So I can say that I know a linear pair, the definition of it, and I'm going to put that little m in front to talk about the measure since we're talking about degrees. So that I know that linear pairs mean that the measure of angle 1 plus the measure of angle 2 equals 180. That's what linear pair actually means. You can add the measures together and get 180. So that is just a definition. The definition of linear pair. Okay. So now we've used our first. Okay, we've used that guy. So we've already used our first given information. Let's look at this second piece of given information. It tells us that angle 1 is 135 degrees, which means it equals 135 degrees. So anywhere I see angle 1, I can take it out and put 135 in its place. So I can take out angle 1 in that red equation that we have there, and I can put 135 in its place, and everything else stays the same. The measure of angle 2 equals 180. Well, anytime I take one thing out and put something else in its place, it's called substitution, because we're substituting one number or one value for another. And then it just looks like an algebraic equation that we're at right now. So I can just subtract 135 from both sides. And I can get that the measure of angle 2 equals 45. And all I did was subtract, so that's just subtraction property of equality. And that is what we are trying to prove. The measure of angle 2 equals 45. Remember, that's what we started out with all the way up here. So we can be D, U, and done. Okay, these are not all three angles that are adjacent. They're all three separate angles, but that's okay. So let's go ahead, and if you want to, you can pause the video for a minute, okay, and see if you can kind of come up with some reasoning to start this proof with. If not, I'm going to go through it here in just a second. So go ahead and pause. Okay, so hopefully you had a chance to maybe get started on some reasoning here. Okay, so I have my given information. Let's write that down. Angle 1 and angle 2 are complementary angles. That's given. Okay. I also know that angle 2 equals angle 3. We could also say the measure of angle 2 equals the measure of angle 3. That's also given. Okay. And we ultimately want to show that 1 and 3 are complementary also. And again, right now, in your mind, a little bell should be going off. I see a vocabulary word, complementary. What does the word complementary mean? Well, the definition of complementary means that two angles add up to 180 degrees. So that would be, in this case, given our first statement there, angle 1 and angle 2 are complementary. We could say that angle 1 plus angle 2 equals 90 degrees. And how do we know that? Well, there's a vocabulary word, and we can use the definition of complementary. Okay, so we've used our first given information, keeping an eye on what are we trying to prove. We're trying to show that 1 and 3 are complementary, or that they add up to 90 degrees. So I notice here that angle 2 is the same as angle 3. So anywhere I see an angle 2, I can take it out and put angle 3 in its place. So that's what I'm going to do. I'm going to take out angle 2 and put angle 3 in its place. Angle 1 plus angle 3 equals 90 degrees. Well, anytime I take one thing out and put the next thing in, I'm just substituting. That's just substitution. Okay, so now I have angle 1 plus angle 3 equals 90 degrees. Well, what is the definition of complementary? It's biconditional, which tells you that if two angles add up to 90 degrees, they're complementary. And it also says if they're complementary, then they add up to 90 degrees, which means we have a statement here that says these two angles, 1 and 3, add up to 90 degrees, which means angle 1 and angle 3 are complementary because that is the definition of complementary. Remember, it is biconditional. Up here, we said that if they are complementary, then they add up to 90 degrees. Here, we're saying if they're 90 degrees, then they are complementary. So it's biconditional. It goes both ways. Okay, let's try one more for today with angles. Okay, so let's take a look at our diagram here and what our given information is. So our given information is that KM bisects LKJ. Okay, all right. That should hopefully right now in your mind be saying, I see a vocabulary word in there. I should probably know what that means. So let's start though with just writing down our given. So we have KM bisects angle LKJ. That's given. That's all they tell us. Okay, but I should be thinking in my head, uh-oh, I see a vocabulary word, the word bisect, which means what does bisect mean? The definition is that it breaks the angle into two equal pieces. So if I'm angle 1 and angle 2 are the angles that are created by that bisect, that means that angle 1 equals, let's call it the measure of angle 1 equals the measure of angle 2. Okay, and that is just the definition of bisect. Okay, well, if we're looking at this, and remember from the very first, I think it was the very first slide, if I have a diagram and I have a ray coming out of the middle, the only other thing I really know that I can do with that is I can add the two angles together. Okay, I can add them together and they equal the whole. So I know that if I add angle 1 and angle 2 together, I will get the whole angle. So we can write that as an equation. We can say that the measure of angle 1 plus the measure of angle 2 equals the whole angle, which is LKJ. And that's just an equation we can write using our angle addition. So that is just angle addition. Okay, just taking the two parts of a big angle and adding them together. All right, so now I have something else to look at here. If I notice, I have angle 1 equals angle 2, which tells me anywhere I see angle 1, I can put an angle 2. Anywhere I see an angle 2, I can put an angle 1. Well, let's look at what we're actually trying to prove up here. I am trying to prove, there we go. I am trying to prove that if I need to get two angle 1s on the same side of the equation up here. Okay, so I need to have, basically I need to have angle 1 plus angle 1. Well, I can do that because I know that anywhere I see an angle 2, I can take it out and put an angle 1 in its place because they're interchangeable. So I can say the measure of angle 1 plus the measure of angle 1 equals the whole thing. And all I did there was I substituted. I took out angle 2 and I put angle 1 in its place because angle 1 and angle 2 are interchangeable. Well, now I have angle 1 and angle 1, two of them on the same side. I can combine my like terms and I can get 2 measure of angle 1s equals LKJ. And all I did there was I combined like terms. So what we're going to do moving forward here is we are going to work on some more proofs. Some of them will be segments, some will be angles that you're going to work on in groups, work on individually, and hopefully ask questions of the teacher, and we can help you with your logic and your reasoning. Again, the more that you do with these, the better they get and the easier they become. So good luck.